if we have a microbiome that has more or has microbes that express more of this BSH, we can actually change how our body is basically metabolizing these macronutrients, which is pretty incredible. So a good kind of showcase of this was, again, another animal study. This was published in Science in 2023, so fairly recent, where they basically demonstrated that if you take a trained animal that is fed, a normal mouse diet, a normal chow diet, and transplant their microbiome into what we call a germ-free mouse or a germ-free animal, meaning that they have no microbiome, that's completely sterile. So you're completely providing a novel microbiome into these animals. So if you take a trained microbiome and you put it into a germ-free animal, what they found after 8 weeks is that animal was actually able to express a lot of this biosalt hydrolase, deconjugate a lot of bile from getting fed a high-fat diet. And actually, as you can see here, the change in the bile acid pool with the increase in biosalt hydrolase activity, but actually not even exercising, have increased signaling of important triggers of muscle metabolism and adaptation to exercise, including AMPK as well as IGF-1. So this is absolutely profound. And we did not see this when we were looking at animals that were provided basically a microbiome coming from an untrained donor mouse. So here we see this deep connection occurring from a pretty understudied area in terms of adapting to exercise bile acids. So if you think about, say, like an athletic diet, generally it's higher in total energy content. Now, it's not to say that athletes are consuming a lot of fat, but it shows that a trained microbiome can better handle fat and actually use that for the benefit of actually adapting to exercise and improving muscle physiology.